Which one of the following is not a subspace of square matrices over R? For option associated this problem is given as W3 is this set where trace of A is 0, and if A belongs to W2 then determinant of A is 0. In W1 first element is 0, and in W4 transpose of the matrix is same as given matrix. So we test these options one by one and reach the final answer. So for option A, in which a trace of A is 0, trace of A is 0, if this W3 will form subspace, then it will follow the all three's property of subspace test. As 0 matrix belongs there means any square 0 matrix. Suppose this is 2 by 2 matrix, then this is trace of this matrix is also 0. So that 0 matrix belongs in W3. Also, if A is in W3, then CA will be in W3 because diagonal elements will increase or decrease by the same element C. So again trace will be 0 because of you can consider if diagonal elements are A, B, C, D, and these diagonal elements are of A, then you can multiply these diagonal element by C, then their sum all again will be 0 because of distributive property. If we are taking two elements A and B, then their sum will be 0 because of diagonal sum. If A, B, C, D are diagonal elements, suppose four elements I have chosen, then their sum is also 0 and this sum will also 0. So sum of diagonal elements, when we taking sum of the matrices, then diagonal elements will become 0, means their trace will be 0. So option A is subspace. Now come to option B. As in option B, what is option B? In option B, determinant of A is 0. So 0 matrix is there is no problem. If we are taking two elements 1 0 0 1 0 0 0, determinant of this one is also 0 and determinant of 0 0 0 1 is also 0, but their sum is identity matrix of order 2, and their determinant of this matrix is not 0, means sum of two matrices is not in W2, so W2 is not a subspace, and we are interested only in which doesn't form subspace. So B option is a correct choice. Now let's see option C and D. If any element in W3, then first element or first pivot position means A11 entry is 0. Then in 0 matrix first element is also 0, means in principal diagonal. In sum also, so W1 is also subspace. Now W3, now W4 means option D. So W1 is also a subspace. Now come to the point, option D. In W4 having the property A transpose is A, means real symmetric matrix. Sum of two real symmetric matrices is again symmetric. There is scalar multiply by any scalar, real scalar, then it is also symmetric matrix, and 0 matrix is again symmetric matrix. So option D forms subspace. So correct choice is only option B, where W2 is not forming subspace.